Welcome back to the deep dive. Today, we are undertaking what is, well, it's arguably the ultimate cold case.
The ultimate cold case. I like that.
We're investigating the possibility that an advanced industrial civilization existed right here on Earth millions of years before humans ever, walked upright.
It's a mind-bending idea, and it definitely feels like something out of science fiction.
Right.
But what makes this a really profound scientific question is this principle of geological erasure. We're not asking if, a city like New York is buried under the ice somewhere.
No, nothing that simple.
Not at all. We're using what scientists call the Silurian hypothesis,
Hmm.
which, funnily enough, is named after a classic Doctor Who creature, to ask a much, much harder question.
And that question is?
If an industrial civilization rose and fell, say, 50 million years ago, could any trace of it, any subtle hint, actually survive the Earth's relentless recycling process?
Okay, let's unpack this because the scale of time we're dealing with here is just staggering.
It is.
I mean, to us, history is ancient if it's 3,000 years old. Our whole concept of the deep past, the pharaohs, the Roman Empire, even the dawn of our own civilization, that only stretches back, 10, maybe 12,000 years?
And that feels like an eternity to us.
It does. It fills libraries. But in geological terms, that is, it's absolutely a blink of an eye.
It's less than a second on the planetary clock, truly. Earth is roughly 4.5 billion years old.
4.5 billion.
Exactly. And for the vast majority of that history, the planet was, well, it was radically different. The key thing to understand here is that the planet is an incredibly efficient recycler.
So evidence doesn't just get buried?
No, it gets actively destroyed and remade. The survival of anything, a footprint, a bone, a piece of shell, for more than even a few million years is, statistically speaking, an extraordinary event.
I remember reading about the contrast in durability. We sort of assume our things will last, but wood decays. Most metal just rusts away.
Right, it corrodes.
And even bone dissolves, especially when you subject it to the heat and pressure of being buried for eons.
Precisely. We rely on the fossil record to reconstruct ancient life, but that record is notoriously incomplete. We often say it's spotty at best.
Fossilization is just so rare.
It is. You need a perfect storm of circumstances. Rapid burial, then mineral replacement, protection from erosion later on. It's so unlikely. I mean, even the dinosaurs who ruled for 150 million years, they've left us with only a tiny, tiny fraction of their population fossilized.
So if finding a single skeleton is a rare event, finding a whole city, that probability just drops to basically zero.
It approaches zero very quickly.
And this is where that geological concept of unconformities comes in, isn't it? It's like we're trying to read a planetary history book that's not just water damaged. It's actively missing huge sequential chapters.
That's a perfect way to put it. An unconformity is a break in the record, a gap where a large period of time is just gone. It was either eroded away, never deposited in the first place, or just warped beyond recognition.
So a civilization could have existed entirely within one of those gaps.
It's entirely possible. If we're looking for a society that lived, say, 75 million years ago, it's not just that the evidence would be deep underground. It could have existed in a time frame that's been utterly erased from the rock record.
Wow. That immediately makes the search for physical structures seem impossible. We are talking about active planet-wide forces that are just working against preservation.
Yeah.
So let's detail these great erasers, the things that guarantee total surface destruction.
Okay, we can start with the most basic one, weathering and decay. When we talk about how long materials last, we usually think in human terms, centuries.
Yeah.
But rain, wind, frost, oxidation, all of that
Sure.
quickly degrades almost everything we build. A modern city, steel and glass, if you just left it alone, it would stop being recognizable within a few centuries.
And after a few million years?
Gone. Any surface traces, roads, buildings, even shallow foundations, are just ground into fine dust.
But the truly terrifying erasure comes from below, right? From the planet's internal furnace.
Indeed. Plate tectonics is the ultimate global shredder. The Earth's crust is not static. It's constantly recycling itself.
So the seafloor is actually much younger than the continents.
Much younger. Most of it gets pushed under the continental plates in a process we call subduction. It gets heated, melted, and mixed back into the mantle.
Which means if a civilization built anything near a coast, or if they were a marine civilization,
Then those traces are almost certainly destroyed, melted down into magma tens of millions of years ago.
and when you zoom out, the movement of the continents themselves is just staggering. We look at a map, and it seems fixed, but over deep time.
It's a dance. Continents collide, they pull apart. We always talk about the breakup of Pangaea, but I find the evidence in shared mountain ranges even more powerful.
Oh, yeah, explain that.
Well, think of the Appalachian Mountains in the eastern United States. They share ancient geological roots with mountains all the way across the Atlantic, in Scotland, and even Morocco. It confirms that those land masses were once smashed together and then violently ripped apart, moving thousands of miles. That process guarantees total obliteration for anything on the surface during those events.
It makes you realize just how unstable the ground beneath our feet really is. And even more recent, sort of smaller shifts have wiped massive areas of land right off the map.
The Ice Age is a perfect example of this, of rapid erasure through climate change.
Right.
At the peak of the Ice Ages, so much water was locked up in these huge ice sheets that global sea levels dropped by over 100 meters.
Creating land bridges.
Exactly. Massive coastal plains and land bridges. Think of Doggerland, which connected Britain to Europe, or Beringia between Siberia and Alaska.
Lands that were probably inhabited.
Thriving habitats, for sure. And when the ice retreated and the seas rose, those vast regions just vanished beneath the waves. Any evidence of life there is now hundreds of feet underwater, either totally inaccessible or just destroyed by currents.
So the message is pretty clear. Buildings, bones, metal, even the land itself, it doesn't survive geological time.
Not in a recognizable form.
Which is why the approach from scientists like Gavin Schmidt and Adam Frank back in 2018 with the Silurian hypothesis idea is so important. If the physical artifacts are gone, what's left to look for?
We have to stop thinking like archaeologists looking for ruins. We need to start thinking like forensic detectives who can't find a body or a weapon or even a witness.
Okay, so what are you looking for?
We have to focus on the indirect, durable markers. Geochemical anomalies that are literally baked into the sediment layers themselves. We're looking for signs of a global, rapid, high-energy impact.
Geochemical anomalies. Right, let's break that down. What are the key fingerprints an industrial civilization would leave behind that could survive for millions of years?
Well, the primary focus is on stable isotopes, particularly carbon, but also things like oxygen and nitrogen.
Okay.
Our industrial civilization, for example, is defined by burning colossal amounts of fossil fuels, coal, oil, gas. When we burn them, we release all this stored carbon that is isotopically distinct from the carbon cycling in the atmosphere today. Well, fossil fuel carbon is depleted of an isotope called carbon-13, and it has basically no carbon-14, which decays pretty quickly.
So burning it changes the overall ratio of carbon in the atmosphere. It creates a unique isotopic fingerprint.
Exactly. And that shift gets recorded and preserved globally in deep sediment layers. It's like tree rings or ice cores, but on a massive planetary scale. So if an earlier civilization used a fossil fuel on that kind of scale, they would have created a similar sudden spike in the ancient rock record.
Beyond carbon spikes, what else is part of this forensic trail? I mean, could we find their plastics?
It's possible. We'd look for evidence of synthetic materials, things that just don't occur in nature. Now, most modern plastics degrade relatively quickly.
Right.
But some highly complex, durable polymers, and especially microplastics, are being deposited globally today. If a previous civilization used materials like that, their unique chemical signatures, their molecular breakdown products, could, in theory, survive for millions of years in some very specific, well-preserved sediment.
That's a terrifyingly plausible idea. What about the industrial gump itself, the residue?
You'd look for industrial byproducts, things like coal ash or fly ash that find particulate matter from high-temperature combustion, or maybe highly unusual concentrations of rare elements that we associate with large-scale mining and manufacturing.
For instance?
For instance, if they mined lithium for advanced batteries or refined rare earth elements for computing, those concentrated elements might be chemically preserved in a localized, non-natural layer.
But this is where it gets really complicated, isn't it? Where the evidence itself becomes super ambiguous, because natural events can produce similar fingerprints.
This is the core interpretive challenge. It raises a truly important question. How do we tell the difference between intelligent action and just a massive natural disaster?
And you have a prime example of that, right?
The most notorious example is the Paleocene-Eocene thermal maximum, or PTM. It happened about 56 million years ago. During the PTM, the planet saw an incredibly rapid global warming event, a massive, massive influx of carbon into the atmosphere that just threw the whole carbon cycle out of whack.
And the geochemical signature of the PTM looks strikingly similar to what we'd expect from a massive industrial civilization pumping out greenhouse gases.
Yes. The sheer magnitude of carbon release during the PTM rivals the scale of what humanity is doing today. So when geologists look at a rock layer from 56 million years ago, they see a sharp warming event and a huge carbon spike.
And the default assumption is?
The scientific bias is strongly rooted in uniformity, assuming natural processes are the cause. It is extremely difficult to distinguish a massive, fast-forming natural event from intelligent industrial activity.
But isn't that maybe a failure of imagination on our part? If the evidence is sharp and global, a single rapid geochemical disturbance, why is massive natural event always the default explanation over intelligent action?
Because the burden of proof to overturn the entire timeline of life on Earth is just. It's immense. It requires more than just an anomaly. It requires an anomaly that is utterly inexplicable by any known geophysical process we can think of.
So a weird chemical trace would just be dismissed?
Almost certainly. A faint trace of a synthetic polymer or an unusual rare earth deposit would be classified as a natural but unusual mineral formation, long before anyone seriously considered pre-human industrial intelligence.
Okay, so let's flip the question. That might provide some clarity. If future scientists dig into our present layer, the Anthropocene, say 50 million years from now, what clear and indisputable evidence of our industrial age would they actually find?
Well, they won't find our monuments.
That's the great irony, isn't it?
It is. Our biggest, proudest structures, skyscrapers, bridges, highways, they're just not built to survive geological time. They're temporary. After 1 million years, they are gone. Our most durable markers will be the planetary modifications. Precisely the chemistry. A sharp global spike in carbon dioxide recorded in the sediment. The synthetic chemicals we've released, things like altered nitrogen cycles from fertilizer use,
And the nukes.
and the radioactive isotopes from the mid-20th century's nuclear tests, that forms an incredibly sharp, globally distributed marker layer. These chemical changes are so widespread and so profound that they'll form a thin, durable signature in the rock record.
It's fascinating to realize that our ultimate legacy won't be architecture or art. It'll be residue, transformation, chemistry, the geochemical disturbance we caused.
And if you want to think about what physical things might last the longest, it's not the monuments. It's probably our most stable landfill.
Really? Landfills?
Oh, yes. After millions of years, the deepest, most compressed parts of our landfills, full of rare earth metals from all our discarded electronics, complex plastics, industrial ceramics, they will represent the densest concentration of technologically modified material on the planet. They will be our ultimate archaeological time capsules.
That brings us to a final, really compelling counterpoint. The case for total invisibility. What if a civilization got really complex without ever developing heavy industry?
It's a great question because it challenges our fundamental assumption that advanced has to equal industrial. A civilization might have achieved sophisticated astronomy, medicine, social organization.
But built with different materials.
Exactly. If they built primarily with sustainable or organic materials, wood, plant fiber, complex biological constructs, and they lived in high-decay environments like a rainforest or the ocean, their remains would vanish. Not in millions of years, but in centuries.
A society that literally chose to live lightly on the planet.
A society that minimizes geological impact might have achieved a kind of successful invisibility from a deep time perspective. They would be a civilization that left no discernible geochemical spike, no concentrated synthetics, and so no recognizable signature for us to find.
And even if we did stumble upon some faint signal, a weird mineral deposit, a slight chemical spike, the scientific framework we have right now would demand we classify it as a natural anomaly first.
That's the default.
So the silence from millions of years ago isn't necessarily proof of absence. It's just a testament to the staggering power of geology and maybe the limitations of how we look for things.
The Earth is a patient and very thorough eraser. If we want to find evidence of deep-time predecessors, we have to abandon the search for ruins and instead focus on those enduring chemical signals, those subtle, fast-formed anomalies. We now understand that our own most lasting legacy will be exactly that, a sharp geochemical disturbance.
So let me leave you with this final provocative thought. If a civilization chose to live so lightly that it left no durable trace, perhaps the true measure of its success wasn't the size of its monuments or the sharpness of its geological signature, but how quietly and completely it managed to vanish. Was their goal endurance? Or was it transcendence? Something for you to mull over until our next deep dive.